Hi all, welcome to the video. In this video, we are going to talk about virtual pod autoscaler in GKE, how it works, what are the options we have. So basically, virtual pod autoscaler adjusts CPU and memory request for individual pods based on the actual workload behavior. So instead of adding more pod replicas, it performs vertical scaling by increasing or decreasing the resources for a single pod. So it will not like add multiple replicas. Basically, it will add more CPU and memory inside the same pod. While in HPA, like we have seen in the previous video, it will add more replicas, but it will just perform vertical scaling by increasing or decreasing resources. And it continuously analyze both real-time and historical usage metrics to determine the optimal resource allocation, and based on that, it takes the decisions. And when a pod is under provision, the VPA recommend higher resources request to avoid performance issues, and when pod is over provision, VPA suggests lowering resource request to improve efficiency and reduce the cost. So like this VPA works, and there's some core components of VPA. First one is recommender. It will collect historical resource usage metrics and then analyze like such events like OM kills, and based on that, it calculates optimal CPU and memory requests based on the observed patterns. After that, there's one other component is updater. It monitors the VPA recommendations and it evicts running pods when required so that they can be recreated with the updated resource request. So suppose there's a recommendation that a pod must have like more CPU and RAM, so updater can evict the pod if it cannot do in place upgradation, and it will evict and recreate the pod with the updated resource request. And there's admission controller also. It intercepts pod creation request and modifies the pod specification to inject recommended CPU and memory request before the pod is scheduled. So these all three works together. These are the core components of VPA, but in GCP we don't need to install the VPA. We have to enable it, and it will automatically install on your cluster. But if you are running any on-prem cluster or something like that, then you maybe need to install the VPA. So there are some VPA modes which you can choose when you create your VPA in GKE. So first of all is off. It will status will be active and it will just generate the recommendations only. It will not apply to any pods. So there is no pod required, like restart required, and just save observation and analysis. So you want to see some recommendations. So suppose you want to see only the recommendation part and don't want to apply those to the pods, and maybe you need to take those decisions later on with why maybe some critical application is running and you want to do when downtime is there, so you can put update mode of it as off. After that is initial, so it applied recommended resource request only at pod recreation, like or no updates afterward. And so suppose if what will happen, suppose at any time your pod will restart, or you have done a new deployment in which new pods will be created, that time it will just create the new pod with the applied recommendation resources. So maybe at that time it will increase or decrease the resource like CPU or memory, and pod restart required is not required, and it is for stable workload and it will avoid disruption. Then we have recreate option. It will evict the pod and recreate it with the updated resource request. So it will just delete the pod and recreate it. So in this pod, restart is required, and where restart is acceptable or in place resize is not supported, then you can use this recreate one. There's one more new option in place or recreate. In new versions, it is available as of now in beta, and it will attempt in place resource update. So it will not restart the pod or anything, and falls back to the eviction if not possible. If in place will not work, so then it will fall back to eviction, that it will recreate the pod, and sometime pod require like restart required, not always. And it will for production workloads that require minimal disruption. Then we have auto, that is deprecated. Auto and recreate is kind of same. Now it will be known as recreate. Strictly it will behave like recreate only, automatic eviction. To apply changes, it is for legacy configuration, but it's still many people use it. So there is an example. So when you enable the VPA, so it will provide an recommendation, like you can see recommendation provided, and the recommendation part it will give something like this: lower bound, target, uncapped target, and upper bound. So let's see what are these options. Lower bound means minimum request to ensure stability. So this is the minimum you want to need to run your pod. This is the target one, ideal request within policy bounds. So target will in which your pod will move or according to your VPA mode. So if you have do an initial recreate, this is the target which will VPA try to achieve. This is uncapped target recommendation without considering min or max limits. It will just give an uncapped target without any min or max limits. You can even define minimum and max limits also, like how much your pod can take, like minimum 100 of MCPU and maximum 800 M of CPU. You can define that those limits also. And then we have upper bound. So it is a maximum request allowed by VPA policy. So we will see all these things in our demo. Now, if we come to HP and VPA comparison, so as we see in the previous video also, so first of all is scaling approach. So it will increase or decrease the number of pod, like that is horizontal scaling. That's why it's horizontal pod autoscaler, and it will just adjust the CPU and memory request for individual pods. It will not like add or delete the number of pods. Pods will be same. Just it will adjust the CPU and memory request. Primary purpose will be handles traffic spikes, like by distributing load across multiple pods, and it is for optimize resource allocation per pod to improve efficiency and stability. Metric support, like it supports CPU and memory by default, and we can use custom and external metrics also. But it is only supports CPU and memory metrics. It doesn't support custom or external metrics. Impact on pods, we can see it can create or terminate pods based on the demand. It can may update resource in place or recreate pod depending on the update mode which you have chosen. There's some limitation like does not adjust individual pod resource size. It may increase infrastructure cost during scale out because it add more number of pods during scale out. It can cause pod restart depending on the mode you have chosen, and does not scale replica count. It will just add more resources inside a single pod. There are some limitations also for VPA. First of all is pod restart impact. So as we know that VPA may apply updated resource request by restarting the pods, and which can result in brief service interruptions depending on the updates mode you have chosen. And HPA interaction risks. So if you are running both HP and VP on the same resource matrix, like on CPU and memory, they can create conflicting scaling decisions and lead to instability. So don't use both on a single thing, like for so basically don't use HP and VPA together, it can create issues. And there are some admission constraint in VPA. So if VPA recommend resource values that exceed available node capacity, so the admission controller may reject the pod, preventing it from being scheduled. So suppose your VP recommends like it needs 2 GB of memory, but that same memory is not available on your node. So the admission controller may reject the pod and it will be in pending state only. So it can create some issues with the admission constraints and controller dependency. Like VPA manages only pods controlled by high-level controllers, such as deployment and stateful sets. Standalone pods are not automatically adjusted. Like if you're running a single pod, it will not work. Use VPA with deployments or stateful set. And some OOM mitigation limitation. So when VPA, we know that it can increase the memory request to reduce out of memory termination, but it cannot predict like rare or sudden memory spikes. For that, you can use HPA, but this is not good for like sudden memory spikes. And there is some scalability consideration also, like VPA may not work very good in a very large cluster, and it may require extra validation, and proper testing is recommended before using VPA in large scale production deployments. And cluster capacity limits, like if it recommends some resources that exceed your cluster capacity, so pods may remain in pending state until sufficient resources become available. Until you add like new nodes or new node pools, it will remain in pending state. And if you are like using multiple VPA policy, so if you apply more than one VPA object to the same workload, and it can result in overlapping accommodations and scheduling conflicts. So these are some limitations which you have to take care while using VPA. And let's go to console and see. I'm not expert in like VPA. It is a new concept for me also. I have not used much in GKE. So let's see how we can use it. So I'm in my console and I have a cluster running. So if I go into my cluster, so for using VPA like virtual pod auto scaling, we have to enable the VPA in the cluster level also. So if you come under automation, you will find here like what vertical pod auto scaling, you have to enable it at the cluster level. And you can see it is also saying vertical pod auto scaling automatically analyze and adjust your container CPU request and memory request. So let's enable it. It will take about 10 to 50 minutes to enable it on the cluster level because it will done all the configuration and install all the important parts in the cluster. So let's wait for 10-15 minutes and then we will start our demo. Also, you can enable it while creating the cluster also. So we have enabled that vertical pod auto scaling. Now let's go to my cluster and do ls and I have some files. So I will go to this folder. This file VPA CPU dot VPA testing CPU.yaml. Let me do this. So basically in this I am running a deployment in which I have two replicas and I have a image code cloud. I'm using a code cloud image because they have some good example to use VPA. And after that I have a running a service. On this service I'm using some target port and node port. So let me deploy this. This is a very simple thing. Like, so I have created my deployment, and if I run kubectl get pods, and we can say container creating and kubectl get service. This is a node port service I'm just using, and this is my cluster IP. And let me see the pods once again. The pods are now running. Let's go to cluster, and if we come to workloads, we will find that our application is running here. And let's go into Flask F4, and from here also you can enable the cluster like vertical pod auto scaling. You can click on this vertical pod auto scaling. As of now it is not configured, and as of now it shows three modes. Off is not shown here, but if you like apply some YAML file it will show off also. So we have auto initial and in place, and you can even add resource policies like how much CPU or memory like VPA can use. So before we enable from here, let's go to our console, select here, and I will show you one file cpu.yaml. So this is a vertical port autoscaler, and it is going to use my deployment as a target. And in this we have update policy as off. So it will just give some recommendation. It will not do anything. And after that I am defining some container policies. The minimum allowed, like minimum 100 CPU must be there, and maximum it can use 100 of 1000 M of CPU, and control resources CPU. So it will work only on CPU. We are not touching memory. So just click on kubectl apply -f like VPA -cpu.yaml, and it will apply this file. And if we come back here and just refresh it, we can see here also like we have vertical pod autoscale. Autoscale is currently paused. Let's click on this and let's see why. So because now it will showing off also, like it will do not assign new values, but controller object can still be queried for suggestion. It will only give some suggestions to us. And if we come to policy, we can see we have a policy that is for CPU, and you can choose for any like default policy for any container, or you can choose the container name also. Like we are running on a single container, so we have choose like asterisk like star, so it will involve all the containers in a pod. And we have CPU like minimum 100 and 1000 and maximum 1000. And if we run kubectl get VPA here, we can see it is in off mode. CPU it is showing us 100 M. And like if we now let's send some traffic on this to test it. Before I do that, let me do kubectl top pod, so we can see how much CPU memory it is consuming as of now. So it is, we can see 1 M of CPU and 19 MI of memory. Now I'm running loads and uh, like pod, so that from this I can send traffic to my these running deployment. So in this I'm just going to create a file load.sh, in which I'm going to run it. So this is, let me save it first. And if I do cat load.sh, so this is some like it will send some load. So it will run for 1000 seconds and it will run 10 workers, and it will send some traffic on this my node, because I'm using a node pool. As you remember here, I have shown you also, like here I'm using a node port. So I am going to send some traffic on my node on this node, and it will just run this. So now let's run this load.sh. When meanwhile it is running, let's open a new terminal, and from there we will monitor our resources. So if I run kubectl get vp-w, so that we can watch what is going on. As of now, it is showing 100 mm of CPU only. Enabled one more terminal. In this, I am running kubectl top pod. You can see now before it is asking for 1 mm CPU. Now it is on 100 mm of CPU, and it will kept on increasing, I think, as per the loads increase. Now you can see it is 117.109. Soon VPA will also update its recommendation. It will say that the target CPU must be descent at based on that traffic which is being increased, but it will not change anything in our pods because it is in off mode. It will just give some recommendations. So you can see we just get a new like update. It is asking for 130 M of CPU. Let me stop it, and if I do -OEML, because I'm running a simple VPA, like as I'm running a single VPA, so it will just, I can just do -OEML also. Otherwise you can provide a name also. So if we come down, we can see lower bound is 100 M of CPU, that is okay, and it is targeting 130 M. So it is saying at least you must have a pod with 130 M of CPU. And cap target, like it is max it can go, it is asking, and upper bound as you see in the slides also, it is asking for one CPU. So it is upper bound, we can ignore it. Upper bound also it is showing because we have defined in our configuration also. You can see autoscaler is currently paused. It will not going to do anything, and as per this, like, and cat VP, and if I do kubectl get VP -OEML, now it is showing 135, and if I run this also get VPA. Now what we can do, if we want to, like, we are okay with these updates, so I will go to v cpu.yaml. So we have multiple modes. Now let's go to auto mode this time, and once we done this, it will update our pods also. Before, let me show you kubectl get pods also. As of now, both pods are running 10, as of age is 10 minute. Now let me apply this. So now in auto mode, it will recreate our pods. So auto is recreate only as per the slide which we have seen. So we can see the update auto mode is deprecated and will be removed in future API version. You can use recreate initial or in place mode. As I've told you that it is auto is deprecated. Now if I run kubectl get pods, maybe it will create a new pod in a minute or two according to the load. Meanwhile it is doing, let's come here and let's refresh this page also, and we can see now it is showing configured. It is not showing anything, any pausing, and we can see we have now auto mode is in place, and let's cancel it and see whether it is creating or not new pod. So we can see now it has just created a new pod, container creating, and it is just terminating this pod. And if we go here and just do kubectl describe pod and give the pod name, and let's see. And if you go to CPU, we can see it is using 145 M of CPU. So we can see our second pod is also been terminated and new pod has been created. And if you see the load will be still running, and it is using, if you include CTL get VPA also, let's see what is it is recommended as of now. It is showing 158 and go, let's -OEML, and from here it is now showing 150 M. It is just kept on increasing our load. As of now it is running with kubectl get pods. And if we see the latest one, how much it is using, so it is using 150 M of CPU. So this one is using new one, and previous one is using 145 M of CPU. So like this it will just recreate the pods if the like your VPA recommendation will get updated, and it will take some time. And if we remove the load also, it will not just roll like scale back, our load will go away. Like if we stop this, it will not just low like scale back the resources. It will take some time, good time, to move back. As of now it will not doing anything. So now let's stop this our program that is running. And now what we are going to do, let me delete this so that we can see the other option also, because otherwise if we wait it will take so much of time. So let me get my deployment, and let's see the remaining two part also. Let me let me delete the VPA only. Delete VPA. Let me delete both VPA and app. We will again deploy it, but this time we will choose initial option, and after that we will choose in place upgrade also. That is a new one. And let's go to Flask app. We have deleted this also, and let me delete my service also. So now I don't have running any pods and anything. And what we are going to do now, I'm going to run again same configuration. So kubectl apply -f vpa testing cpu.yml. So this has been created. Now let's go to our workloads and we will enable VPA from here only. And if I go to my Flask app, and you can come here also at downwards and click on configure, and here I will choose initial. So it will all like pod upgrades are only applied when new pod is created. And let's create a same policy which I've used before, default only for CPU, and add rule minimum 100 of CPU and maximum is 1000 M of CPU, and just click on done and just click on save, and it is done. Now if we run kubectl, like kubectl get VPA, we will find our VPA here, and it is, you can see the mode is now initial, and soon it will provide the updates when it will get from that recommender, like how much it needs. So it cannot be determined as of now because we have just created, we have to wait some time. Now let's go back and again run this load.sh, and if we come here and run kubectl not nodes, let's get top pod. As of now we will see it is all using 1 mm of CPU. It will just kept on increasing as we have more load will come. So we can see now load has been came 87 mm 130 m, and if we come here and let's run kubectl, we clear this and run kubectl get VPA, and we can see it is now showing 150 m of CPU. And if we run like -o YAML also, and we can see it is asking for target of 150 m of CPU, but it will not do anything until the pod will be recreated, or the initial pod like we have defined here initial thing. Let me refresh this, maybe it will show like it is working fine. Now we can see it is configured, and initial we have configured here. Updates are only applied when a pod is created. So what we can do now, let's come here, let me do kubectl get pods, and if I let me delete this pod, and it will recreate this pod. Delete pod. So it is deleting the pod. The new pod that has been created will be created actually. It must have then updated our target cap. Oh, it has came back to 100 MCPU. I think it will not create now. Now let's run kubectl get pods, and this is the new pod that has been created. Let's see whether it will have the updated. Okay. It is showing 100 mm of CPU because our VPA came down to somehow to back to 100 only. Let's see now what it will be showing. Let me retry it. Maybe it will work. Now it is showing 160 m of CPU. Let's retry it once again. kubectl get pods. Maybe this time it will work. And let's delete the new one only. kubectl delete pod. Just maybe this time it will not go back to 100 only. It is now showing 255 because only single pod is running. Now maybe in a minute or two our new pod will be created, and from into that we will check our resources because it will only apply at the initial level, not at that running level. Now it has been deleted. Now let's do kubectl get pods. So this is our new pod, and if I go here and like just describe this pod, and if we come here we can see now it is using request 255 of MCPU, that is being shown here 255 like this is the initial level which you can use VPA. Now one more thing we can do, Now let's go here and just update it to from initial to let's update to in place or recreate. So this is in preview, so it can update in place also, like without restarting the pod. But if that is not possible, it will do the pod recreation. So now let's click on save, and now let's go back here. As of now, let's see what VPA is showing. It is still showing 255, and you can see it is update to in place or recreate. Maybe it will update our pod also. kubectl get pods, and this is okay. It is just terminated our pod it is not recreated in not done at a in place level. It is just recreating the pod. You can see 30 seconds ago. So it will in place or recreate. It can do anything. We cannot um, comment like what will happen. It all depends upon the like VPA level only. Last time I've tried, it will done the in place also. Maybe this time it is not doing somehow. So like this, you can use all these options in place or recreate also. Like for this, like in place doesn't happen, but it then the recreate option, recreate thing. But in the testing which I have done in my previously, it on that part in place also happens. So, but I cannot show you because it depends upon that VPN on the pod also. And sometime it happens, and if sometime in place resizing is not possible, that pod recreation will occur. That will happen in our demo. So this is all for VPA. This is not like a video on proper VPA, just showing how to use VPA in GKE and what are the options we have. If you have any suggestions or something, just comment it down. I will try to help you and work on it. And you can also try to drop an email. I will drop my email ID. And if you have any question, suggestion, just drop an email. I will try to help you if I know how I can help you. Thank you very much. Bye.